Yay!
Yay! All right, I know we just did an example of finding the electric field due to point charges, but guess what? We'll do another one. You can't do too many. It's just practice, practice, practice. So here's another one to check yourself to see if you get it. Here we go. Now there are 3 point charges, and now let's say I want to know what the electric field is at the origin due to these 3 point charges. We're going to follow the same exact prescription. So the electric field, remember the way that I like to write it is, well, here's the way you see it. KQ over R squared, R hat is the traditional way to write it. But I think it's easier to do this. KQ over R cubed, R vector. Same thing, right? So let's do that. And remember what we're going to do is add the electric fields, add the vectors for each of the 3 charges. So we're going to find the electric field due to this guy. It's going to point towards that charge because it's negative, right, at the origin. And then there's an electric field due to the bottom one, the plus 10, which is going to be pointing up. And then there's an electric field due to the plus 5, which is going to be pointing that way, right, away from it. So at that point in space, I got 3 electric fields. And by the way, oops, let me write this in standard color. This is called principle of superposition. You're going to see this as you go forward in physics over and over and over. All this means is superposition just means that at the same position we have multiple fields, and all we do is we add them together. And they don't interfere with each other, which is nice. So I just figure out what the electric field is due to the -5 charge, pretending that the other 2 charges aren't even there. Then I do the plus 10, pretending that the other 2 aren't there, and so on. So you just figure out the electric field due to each one, not having to worry that the others are even there. And then at the end, you add all those fields together. It's a beautifully simple principle that works in many, many different areas of physics. Okay, so here we go. We're going to do it a little bit faster this time. So what is the electric field due to, let's see, let's do the plus 5. All right, so that's going to be KQ. So it's going to be 9 times 10 to the 9th, 5 times 10 to the -9. So we can shorten that to be 45 over that distance. What is the, oh, I didn't even tell you the distance, did I? This is 2 centimeters. This distance, what did I say this one was? 1, 2, 3 centimeters. This is 4. And it's 3 up here. Okay. So let's see. That plus 5 charge is going to be 2 centimeters away. So it's going to be 2 times 10 to the -2 cubed. And then what's the vector? The vector is just going to be from the charge to the origin. It's going to be 0.02 and 0. Neat. Now let's do the plus 10. So 9 times 10 is going to be 90. K times Q is going to be 90. And that distance is going to be 3 times 10 to the -2. And that's going to be cubed. And then from the charge to the origin, what is that? 0. And then 0.03, because these are centimeters. And then, oh, I guess I'll do it here. This is going to be another 45 over, let's see, what is that distance? It's a 3, 4, 5 triangle again, so that's just going to be 5 times 10 to the -2 cubed. All right, here is the tricky part. This is where most students get tripped up. What's that vector? It's the vector from the charge to the point I'm interested in, from the charge to the origin. So how do I get there? I got to go -4 in the x and -3 in the y, right? So it's going to be minus and minus. And there we go. That's going to be it. So we plug in these things. Let's see. Again, I did it already because it's boring to watch someone do this. So you can check me on this. 1, 12, 500. That's the first vector. Plus, and sure enough, that's going all in the x. And then this one is going all in the y. 0 and 100,000. 100,000. Right? And then this one sure enough, it's a minus. Look, minus, minus, minus. So all those minus signs cancel, and so that vector, sure enough, is pointed up and to the right as it should be. So it's 14, 4, and what else do I get? 10, 8. So my final vector, if I add all these together, is going to be like 126, 900, and what's the other one? 110, 800. There we go. Boom. That's my electric field. We're done. So again, if you have a whole bunch of charges, all you do is you just add up each individual vector, and you know how to find each one. It's just kq over r cubed, r vector. You just add them all up. If you wanted magnitude and direction, that's fine. So if I do ex squared plus ey squared, take the square root, I get 100. So the electric field is 100. You can check me on this, 168,000 about. Again, I don't care much about the units right now, but whatever. Those are the units, newtons per coulomb. And the angle, oops, theta is the angle, is the inverse tangent of ey over ex, and you should get something like, what did I get? 41 degrees. There we go. Okay, so again, just another example, just to kind of check yourself that you can get these. So this is finding the electric field due to 3-point charges. So if you know how to do 3, you can do 4, 5, 11, or whatever, right? That would be really tedious, but there you go. It's the same operation over and over and over again.